Hello, and welcome to SDD353, cross-account encryption with AWS KMS, and featuring Slack Enterprise Key Management Service, or Enterprise Key Management. Ours is Key Management Service. I'm Joe Norman. I'm a Partner Solutions Architect with AWS, and joining me is Audrey Drummond, a staff backend engineer with Slack. And kicking it right off, I'm going to do a little bit of review of just like 100-level KMS, where it fits in with AWS. So looking at defense in depth, if you were to say for this example, pretend you're saving an object into S3 or document into S3. So on the left of this slide, you see users. That's your starting point with identity and access management. Someone's going to log into AWS or use the console. So you've got a user or a role, so you're accessing through that. So with that, you've got a password. Hopefully, you've got multi-factor authentication. At the next level, that user is assigned a role. And that's where you assign the IAM policy, the identity and access management policy that defines the rights of that user to, in this case, access an S3 bucket. At the next level in the middle, there is a networking layer, a S3 VPC endpoint. So that's a networking construct. It's an elastic network interface that when you call S3 from inside your virtual private cloud, will route the traffic to the bucket. So the VPC endpoint has its own policy that allows you to control what actions can be taken against that VPC endpoint and by whom. So you can say user X can or cannot access this S3 bucket. So that's your next layer. After that, the S3 bucket itself has its own policy, its own bucket policy, where you can similarly define the rights of users and roles to access it. And finally, what's going to be the focus of at least my part of the presentation is key management service. And key management service has encryption keys and policies attached to those keys, and it is our key service for encrypting data within AWS. And then finally, when you get through all those layers, you have the data itself. So that's our lowest level, 100-level piece of it, and we'll slowly build up, hopefully, to what you consider 300-level in this presentation. So again, a little bit high level, encryption in AWS. Starting on the left, you've got your clients and your corporate data center accessing AWS services like S3 and Athena and DynamoDB. Behind those, you've got the KMS acting as kind of a silent hero, fairly inexpensive, and it's more of a support service supporting all these other services. So you interact with AWS through S3 or through one of these in most cases, though you can interact directly with KMS through the encryption SDK and other ways. KMS itself does the encryption for these services or for your application, and then behind that, you have services that support KMS itself. So you have access controls with identity and access management. AWS CloudTrail does logging, so anytime you make a change against a resource in KMS, that's going to be logged in CloudTrail, and then those logs are stored in an S3 bucket. And then there's other things that happen behind the scenes as well. So at reInvent 2018, back in November, we announced KMS Custom Key Store, which is an integration between AWS KMS and AWS Cloud HSM. So it basically gives you the ability to use Cloud HSM without not necessarily going through the Cloud HSM client, but instead going through the AWS Key Management Service SDK, like the Encryption SDK and the KMS SDK. So the reason you might want to use the Cloud HSM, one would be compliance level. So KMS, they're on similar hardware. They're all in HSMs. KMS is multi-tenant on its own. Cloud HSM would be single tenant. So that's one reason if you need to be single tenant. KMS is for compliance is FIPS 140-2 at level 2 overall and level 3 for some parts of it, whereas Cloud HSM is level 3 for everything. You also might need to be able to do independent auditing outside of KMS. So you may need to look at access logs. You may want to be able to directly control the HSM, where you can't do that for the HSMs for KMS because they're multi-tenanted. You can do that with Cloud HSM. That's really the idea of it. And then finally, you might need to be able to independently access logs and prove that a key's been deleted independently of the KMS logs and CloudTrail and all that, but to go directly into the HSM and verify that a key's been deleted. So now starting to get closer to the 200 level of the presentation, there's a key hierarchy in KMS. So KMS itself, you don't really encrypt the data. You can, but you don't really encrypt your data with the keys you store in KMS. So KMS, you create a customer master key or a CMK, and then from there you do envelope encryption, which by the end of this presentation, you will know, if you don't already know envelope encryption, you will absolutely know it by the end of this, because you'll see like 5 diagrams of envelope encryption, I promise. So the customer master key is something that stays in the HSMs in KSM, the hardware security modules in HSM. I'm sorry, I keep using that acronym without ever defining it. That never leaves the HSMs. You can delete it, but you can't export it, so it's very secure. And you use that key to create data keys. The data keys are used by the AWS services, like S3. It can be used by your application. And those data keys are used to encrypt data by those services or by your application. And then the encrypted copy of the data key is stored with your data and then sent back to KMS later when you want to decrypt data. And we'll get into a diagram of that. Some of the advantages of doing it this way: you're only sending very small bits of data, sending and receiving very small pieces of data to and from KMS. You're only requesting a data key and getting back a data key, which is much smaller than sending a multi-gigabyte, multi-terabyte object up to KMS and asking it to encrypt directly. I think there's a limit to what you can encrypt directly. I think it's 4 kilobytes, but don't quote me on, well, now I'm on YouTube saying it. But there's a limit you can look up for what you can directly encrypt, but we generally recommend doing envelope encryption instead. And that lends itself to high I/O. You could also cache that data key. So when you request the data key, you're going to get a plain text copy of it so your application can do encryption of data using that key. If you have like a million objects to encrypt at once within a few minutes, few seconds, you can just keep the copy of the plain text key, do your operations, and then delete the plain text key when you're done. So you don't have to make a request for the data key for every single individual file for the same data key. So you reduce your I/O there, your requests to KMS. All right, first diagram of envelope encryption. So we're going to start with server-side encryption with S3 using KMS. So you start out with your plain text data, loaded it into S3, hopefully using something like SSL to get it there. S3 is going to make a request to encrypt that data, and it's going to make that request to KMS. KMS is going to check its key policy, the key policy assigned to that customer master key, to make sure that you've given S3 permission to access this key. That's a service role that you create. Assuming that's all good, it's going to send back both an encrypted and a plain text copy of the data key. S3 is going to take the plain text copy of the data key, use it to encrypt the file, and then it's going to delete the plain text copy and store the encrypted copy along with your data. So getting to decryption, it's got the data encrypted, it's got the encrypted data key. It's going to send that data key, the encrypted data key, to KMS. KMS is going to check the key policy again, make sure S3 still has the right to access that key. Assuming that's good, it's going to decrypt the data key using the customer master key and send it back to S3. Now that S3 has the plain text data key, it can decrypt the data, and you've got your plain text data that you can read. And you'll see different versions of this diagram a few more times in this presentation with little variations. So I mentioned key policies a few times. So what is a key policy? It's an identity access management JSON document that describes the rights of an actor to act on a resource in AWS. So some of the pieces of that. First, you have the effect. It can be allow or deny. So you can make a statement that either allows an action or denies it for an actor to take an action on a resource. That part's simple. The next is the principal, which is the actor. It could be an IAM user, a role. It could be different accounts. We'll see another example with different accounts in a bit. This is where you define who or what is acting on. It could be a server or a role, whatever. And then next you have the action that it can take. So here I'm making an admin role just to keep it simple. So I did KMS asterisk, which would be all the API actions. And generally you want to use least privilege. So if you're doing a non-admin role, you want to do only the API actions that you need for that specific role. And we'll see some examples with some of the other different API actions later. And then the resource, in this case, you just use asterisk to, and that in the case of a CMK, it defines it against the CMK it's attached to if you use asterisk, but it's where you define what is being acted against. So up till now, we've talked about things within AWS. So we need to get a little more broad and talk about what customers are actually doing. So you as a customer of AWS have your own VPC in AWS and other services outside of the VPC, but within your AWS account, things like S3 buckets and such. And you interact with KMS that way directly, kind of what we've seen before. In this case, when you're interacting with KMS, you control the keys. Either the service itself controls it in some cases, things like Amazon Comprehend. The service itself controls the keys, but in other cases, you would control the keys yourself for KMS. And you have full visibility on the whole encryption cycle if it's in your account. But in real life, customers are using things like SaaS. And when you bring in a third party, there's potentially a loss of control. So you're sending data to a third party, and you're trusting that third party to follow best practices with your data, to encrypt your data, to delete keys when you say they do, when they say they will. And basically, you're more or less at the mercy of another company of how they're handling your data and how they're encrypting it, and whether or not they remove access for themselves when you ask them to. So in this case, the SaaS provider, and I use SaaS provider here as an example to keep it simple. It doesn't necessarily have to be, it could be another company that you're just partnered with. It could be all sorts of a managed cloud account for you, whatever. I'm just going to use SaaS. I'm on stage with Slack. Slack has a SaaS, so it makes sense for this presentation. So diving into what they're doing on the SaaS side, here's diagram number 2 of envelope encryption. But we won't do the decrypt side this time. So you're sending your data from the customer side into the SaaS via like TLS or however you want to get it over encryption in transit. Once it's there, they're going to make a call to KMS. They're going to get that plain text and encrypted customer or data key. Sorry, they're going to get the plain text and encrypted data key in their AWS account, the SaaS AWS account. Use it to encrypt the data, delete that data key when they're done, the plain text data key, store it together, and eventually they can encrypt it. All this happens in the SaaS provider account. The customer has no control anymore over the keys or encryption other than making a request through the SaaS. So how can we give the customer more control? So is it possible to make it more balanced? And the answer is yes, and we'll dive into each piece of that. So this is my last diagram of envelope encryption, I think. So the customer can control the customer master key, or let's take that example. The customer creates a customer master key in KMS in the customer AWS account, sets up a key policy, and you can set that key policy to allow another AWS account to access the key. And we'll show an example of that key policy shortly. So you get your data, you as the customer get your data into your SaaS the normal way, and then the SaaS can make a request to generate data key to your AWS account CMK. Then just like before, you're going to check your key policy, send that plain text and encrypted data key to the SaaS, and then they're going to be able to take that and encrypt the data. You also decide to cache that plain text key to do the high IO thing we talked about before, and then eventually delete the key following predefined practices. So on decrypt, they're going to do the same kind of thing. They're going to make a call to the decrypt API in your AWS, you're the customer AWS account. It's going to check that key policy again, and if everything checks out, it's going to decrypt that key, send it back to the SaaS provider, and then I realize I'm pointing the opposite way of what's on the slides, but I apologize for that. Just reverse everything I'm doing. And then you're going to have the ability to decrypt your data, and you're going to have the plain text data. And how does that work how do you set up that key policy? So you set up a cross-account key policy, which is just a key policy, and I've put the words cross-account in front of it. It's not really a thing. So again, you've got effect allow, and here's the big difference is you're allowing a third-party AWS account. So the SaaS provider would theoretically provide you with AWS accounts to use. If it's a partner, if it's another one of your own company's account, even you get those AWS accounts and set them up as a principal. Defining root here defining the user as root gives access to the entire AWS account of that third party in this case. So any user in that account. So actions here, we're getting a little more, you don't want to do action KMS asterisk. I hope you probably don't want to do action KMS asterisk here. You want to define exactly what actions they can take against the KMS API. So in what we saw in the last example, we made 2 API calls, generate data key, which was initially creating the data key and sending back the plain text. There's also generate data key without plain text, which wouldn't be very useful in this case. But you can read up on those. And the other one was decrypt. So when they've already got that data key stored encrypted and they want to decrypt the data, they send the data key back and it decrypts it and sends it back. So those are 2 APIs that we saw in the last example, and resource asterisk. So let's say you're the customer, you've ended the relationship with the SaaS, or you found some non-compliant data one of your users put into the SaaS, and you want to revoke access to to data or to a specific customer master key that you know encrypted a certain data set. So how would you do that? And the way you do that is you add another statement to your key policy. The statements here, if you look at the top left corner, it's an array. So it's just a list of statements. So once again, we've got effect, in this case, deny. So you've still got the allow in place, so this will go on top of that. So it now is going to deny in a more specific case. You're going to deny the same two actions. You really only need to, in theory, you only need to deny decrypt. The reason we've also denied here generate data key is, let's say new data gets into the SAS for the same like time frame or context. You may not want the SAS to be able to like decrypt that new data and be able to encrypt it again later. So you theoretically would want to do generate data key as well here for revocation, but it's optional. And then we have something called an encryption context, and that's your condition. And you can kind of think of this as like a select statement in SQL. It's your filter. So an encryption context is a set of key value pairs. Some are predefined, like date timestamps and such, and some are things you define as when you're writing your application. So in this case, I've got a placeholder for folder home. So it's only going to apply this deny statement when the encryption context of folder and home match on the data. And that's just metadata that's stored with the data key. So it's going to look for that metadata match. If it matches, then it's going to apply this deny policy. So all this stuff that happens in your AWS account against KMS will be logged in AWS CloudTrail. So when your SAS is doing a generate data key request against the CMK and you're the customer's account, you, the customer, will have a CloudTrail log for that. And CloudTrail keeps track of pretty much anything you could want. You don't want it to keep things like the plain text data key responses and stuff, so it does not do that. So going through some of these, we've got the event name, which is basically the API action is taken, a date timestamp, the parameters of the request, like the key identifier. You got encryption context, which we just talked about, the source IP address, and the identity access management, the account and the username. Pretty much everything you would need to log to see what's going on, what requests are being made against your customer master key. And my last slide is some things to consider if you're setting something like this up. So first, AWS KMS is regional. So if you need to do this to make this work across regions, you're probably going to need to set up multiple customer master keys. It's not to say that a third-party application in New York can't access a CMK in the AWS US West 2 region. They don't know what region it's in, but if you're within AWS and you set your, imagine setting your console to a region, you can't get a key that's in a different region. You can't act on a key that's in a different region. So next, the customer this is not no trust. So there's this less trust, but it's not no trust. So you still have to, we saw that with the envelope encryption, the SAS is getting that plain text the plain text data key. That you have to trust is being deleted. If the SAS were to not delete that data key, then there's no control there. They can freely encrypt and decrypt data forever with it. So you have to trust that that's being done, that if a SAS is telling you they're deleting the data key, that they're actually doing it. And this is something that's been solved in the tech world through things like third-party audits. That's how you would approach something like this. When you do have to trust your SAS, you can't use SAS without some level of trust, but you also want to verify, trust but verify. So you've got things like third-party audits and such. And then finally, we have the concept in AWS in general of the shared responsibility model. So when you use SAS, you're taking another adoption of the shared responsibility model where you're trusting, in general, you're trusting if the SAS fully controls encryption, they're responsible for following best practices of that encryption. In this case, you'd be taking back some of that control and therefore responsible for it. So you're controlling the customer master key, not the SAS, so now you're responsible for doing things like key rotation, making sure that you set up the access control rights properly and things like that. So you are taking back more of that shared responsibility model. So that's it for my section. I'm now going to pass it off to Audrey from Slack.
Sweet. Thanks, Joe. Good morning, and thank you for being here, because I know it's pretty early. My name's Audrey. I am a staff backend engineer at Slack, and I'm also the EKM backend tech lead, where I help design, build, and lead a team of engineers to make sure we got this done. So before I go into Slack, EKM, or Enterprise Key Management, I want to give like a quick overview of what Slack is, just in case folks are not familiar with it. So Slack is a collaboration hub that helps people to work. It's a place where you can send messages, communicate with your coworkers in real time, so without the email. There's also Slack Enterprise Grid. So some folks may be familiar with like a single instance of Slack. Enterprise Grid allows like a collection of workspaces to work together. So you can imagine that a user will be like in a particular workspace, and that workspace has a set of channels, and they are only working in that particular area. The reason I mention this is because EKM is only offered currently for Enterprise Grid, and it'll make a difference in some of the slides later. So now we're going to get into the Slack EKM overview. Over the years, customers have been asking us for some sort of control and visibility over their data. And we worked really hard with them to kind of figure out like exactly what their security threat model was, what their concerns were. And based on all of that feedback, we ended up on a solution that integrated with AWS KMS. So the solution is that we now allow customers to bring in their own keys into Slack. This allows them to control the keys that are used to encrypt and decrypt their data. We also allow that there's granular control over those keys. So in the case of that they need to revoke access, they can do it not just for like their entire org, but they can do it for like a set of channels, a set of messages, a particular hour. This solution also allows for some security-conscious customers to be able to have like a lot of visibility into their logs. Joe was talking about using CloudTrail. We also use CloudWatch that allows them to see exactly when and why their keys are being used. So as we were like talking with customers, we had some like high-level design objectives that we were trying to follow in order to come up with the architecture. The first of those was to make sure that we maintained all of Slack's features in its full and unhindered form. Customers didn't just want like, just control and visibility, but they also wanted Slack the way that Slack is. We also wanted to make sure that we inspired a high level of customer trust by providing untamperable logs, and then also augmenting those logs with logs generated by Slack, and then also making sure that Slack employees had no access to those keys. Another objective was to make sure that we could still make sure that Slack engineers could still build new features and deliver bug fixes. There's one thing about having Slack just as Slack, but if you want to make sure that your Slack with EKM still is getting all the newest and latest and greatest features, we want to make sure we can make that a reality for our customers. And lastly, we want to make sure we introduce minimal performance penalties. Like customers and users that are using Slack with EKM shouldn't really know that there's Slack EKM there. So I showed some screenshots of like what it sort of looks like, what Slack looks like without any sort of revocation, but I do want to give some slides about what it looks like when keys are actually revoked on the Slack side and what that user experience would look like. Usually this is not like a day-to-day occurrence based on like what our customers have told us, but this is what it's like. So imagine that in this sales workspace, an admin has realized like, oh, there's some sort of disclosure. We need to make sure that we lock down this channel. They would set a policy in Amazon KMS that would then revoke access, revoke Slack's access to the keys for that channel. So this is what the end users would end up seeing. As you can tell, that's like a pretty aggressive policy, meaning that work in this channel has come to a complete halt. Like people can no longer send messages, they can't read anything. So this is where the more granular control comes in, where you could, or a customer could set a policy that then allows for more granular revocation. So in this example, a policy has been set that revokes for just a particular hour within the channel. This still allows users to go back and like read old messages, but they just can't do anything for like the particular hour that has been set. So Slack EKM provides visibility into the keys that are being used to encrypt and decrypt, and also control of that key access at the hour, channel, workspace, and tower, and organization level, sorry. And I'll go into more about how all this works a little bit later. So now we're going to dive into the architecture of like how Slack EKM works. And at like an implementation level, this is what we did. We encrypt every message or file using the customer encryption keys. We'd decrypt every message or file with the key that was used to encrypt. We use many keys covering a small slice of messages or a single file. We make sure that we give customers all log accesses of their keys. We cache the keys for 5 minutes, and this is purely for performance reasons. As Joe was mentioning, there's ability to cache, and we want to make sure that we're not hitting those Amazon APIs all the time. We want to make sure that we also enable customers to control those key policies through Amazon KMS. So if you were to take a 10,000, 20,000 foot view of what Slack EKM looks like in that architecture, this is something that you would see. On the left side, is that left? Yes. On the left side, that's the Slack Amazon AWS accounts. And on the right side is a customer AWS account. You can tell that it's completely separate. In the customer's account, you have the customer master key, you have CloudWatch, the CloudTrail. That's basically where all of the keys are being generated. On the left side, it's the Slack backend, which we refer to as web app, our databases, which are encrypted at rest, and a separate service that engineers can't access called EKM that actually manages doing all the encryption, decryption, and talking to KMS. So Joe wasn't lying about having lots of encryption and decryption flows, so I'm going to go through a couple of them to kind of speak through what is happening on the Slack side as we use KMS. So if you're in that sales org again and you're sending a message to one of your coworkers saying, hello world, we would end up sending a message. We realize that you're part of a Slack EKM org and then send a request over to our EKM service. That would include some sort of key identifier for the CMK and the plain text message. Once the EKM service receives that, it would then go and send a request out to Amazon KMS to do a generate data key. In KMS, the CloudTrail log would be logged. And this is the log that Slack has no control over, that this is going to happen one way or the other. Then KMS responds with the encrypted data key and then also the plain text version of the data key. The EKM service will then also log to CloudWatch to let them know, give complete visibility into what's going on. The EKM service will then use that plain text data key to encrypt the data and send back a cipher blob to the Slack backend, which then goes and stores the ciphertext into the MySQL databases. So kind of similar to the previous diagram, this is the customer's account, again, completely separate from what Slack controls and builds. And this is the point where the key policy is enforced, again, completely within Amazon's, or within that customer's account. For the decryption flow, it's a very similar thing. You're on your sales workspace. You want to read hello world. The MySQL database loads up the ciphertext. We realize it's encrypted, so we go send that cipher blob over to the EKM service. The service then makes a request to KMS to decrypt the data key. Again, that action is logged into CloudTrail. The plain text data key is sent back to EKM, which then decrypts the data. We send a log to CloudWatch. And at that point, we send back the plain text over to the customer so they can actually read hello world. And again, this is where the customer's AWS account and where the key policy is actually enforced. You may have noticed that I mentioned logging twice here. There's the first time directly from KMS that logs to CloudTrail, and then a second time where EKM logs directly to CloudWatch. I'm going to go show some examples of what those logs look like, but they're slightly different. And we do this because we have the promise of making sure that we're going to send every single log and give as much visibility as we can into what we're doing with the keys. One other thing to note is that the EKM service itself has a 5-minute cache, as I mentioned earlier. So you can kind of think of the logs that are sent to CloudWatch as a log of all the cache hits and misses, versus the logs from CloudTrail are just the cache misses. So I'm going to talk a little bit about encryption context and the key policies. One thing I want to note here is that in some of these slides, I use scopes or key scopes or encryption context. Key scope is a term that we use within Slack, and it's the same thing as the encryption context. So we have 5 sets of encryption contexts or key scopes. It's the organization, workspace, channel, hour, and file. every piece of message or file or message or file related data is encrypted with some combination of those keys. For a message, the combination is organization, workspace, channel, and hour, because a message is written within a channel at a particular time on a workspace that's part of an organization. And a file is encrypted with the organization and the file scope. One last thing to note here is that every piece of data has to be encrypted or have a scope of at least the organization. And I'll show some key policies later that ensures that's actually happening. So if you think about like the granularity of these scopes, you can see like the organization is the least granular, and the time would be the most granular key scope. So here's a baseline policy of what a customer would set up within their AWS account to ensure that Slack has access to their keys. So the effect is allowed because they're allowing access. The principal is the Slack's account, which is like that cross-account policy. The action, and again, we want to like make sure this is scoped to exactly what you want the customers to do, or Slack to do, is the decrypt action and the generate data key action. And then the condition there is really important because this is where we call out that the organization scope needs to be present in order to allow access to these particular actions. So if for some reason Slack sent a request that didn't have that organization scope in it, it would be a deny policy, and they wouldn't be able to do anything. This is what a policy would look like with a baseline lockdown. So let's say that the admins have decided that they need to revoke Slack's access to everything. They would set the effect to deny, and this makes the organization work basically come to a halt because there's no longer, we can't encrypt, decrypt, or do anything in any part of the org. So I saw this example a little bit earlier about what a channel revocation looks like, and I also want to show like the corresponding policy for that. So here we can see that the effect is deny, and the difference here is that in the condition, there's a new condition there that says encryption context C and a particular encoded channel ID. This means that any decrypt or generate data key requests with that channel context in there will now be denied. Here's an example of a policy, of like a combo policy again, for a lockdown, the organization for a particular month. The effect is again deny. You see like the baseline condition in there for the organization. And then you see an additional condition that says the encryption context for an hour of June 2019, and the wildcard for the date and time should revoke access. So anytime before June, so like May, April, March, you'll be able to still see all your data, but anything within June, you won't be able to read or be able to send messages. But once next week happens, in July, you'll be able to get back to it. Here's another example from earlier where the policy was set that revoked access for a particular channel, but for a particular hour. And the policy here would look something like this, where the effect is again set to deny. In the condition, the baseline condition, we add in the channel again to say for this particular channel. And then we also have the time condition, which is the 25th. Is today 25th? Yeah. And then for a particular hour. One thing to know about the hours is that it's in UTC, and that has caused some fun confusion as we built the product. Now I'm going to talk a little bit about visibility and get back to those logs that we were talking about. There's CloudTrail, there is CloudWatch, setting a lot of logs. Here are some examples of what they would look like. I've definitely pruned these down a bit because there's a lot of data in there, but this is the portion that is really important. On the CloudTrail side, you'll see the event name is decrypt because we're decrypting some data or decrypting a key. The encryption context, again, it's like the channel, workspace, hour, and organization. On the right side are the CloudWatch logs, and these are the logs that come directly from the EKM service. You can see the keys are named a little bit different, like there's action, the key scope, again, key scope and encryption context are the same. And then the really important part is the reason. So this is what helps give customers the complete visibility into like why we're doing a particular action. We have a bunch of different codes, including history, saying like someone's like reading a message, saying someone's sending a message, or uploading, search indexing, export, discovery, et cetera. So this is what helps give our customers as much insight into into what we're doing. So just to wrap up, Slack EKM, the most important thing is that Slack remains Slack. We're still able to do, keep building features. We're able to have customers use the product. But in addition, admins gain control and visibility into how their keys are being used. And with AWS KMS, it makes it super fast and highly available. We actually launched EKM a few months ago, and it's out in the world. It's live. Customers are using it. And folks from government agencies all the way to consultants, and they're getting a lot of use out of it. Anyways, thank you very much for your time, and it's been rad.
Questions?
Huh?
If you have any questions, just meet us right outside the room.
Right.
Yeah, we won't take them here because we don't have mics set up for you, but just meet us out there. We'll be there for a few minutes. And don't forget to take the survey. Thank you.
Thank you.